Hello, this lecture is on air pollution. Some of this will be a review of previous topics discussed this year. Some of it will be new. There are two main types of air pollution. We have primary air pollution and secondary. Primary air pollution is the first air pollution being produced. Some examples: we have carbon monoxide, carbon dioxide, sulfur dioxide, and nitrous oxides. We also have hydrocarbons and suspended particles such as dust in the air. Secondary pollution is when primary pollutions react with something else or with each other, or something like sunlight, to produce a new pollution. And these are some of your examples. O3 is your ozone. If you'll notice in your primary pollution, the subscripts are 1 or 2s, and your secondaries we have lots of 3s and 4s. That's because the molecules are getting bigger. These numbers at the end should be subscripts. However, they didn't import very well, so they look like normal numbers. The negatives should be superscripts, so they should be at top. Okay, here's a quick little gut diagram to show you some sources of primary versus secondary pollution. We've got natural sources, dust blowing off from exposed soil, factories, your car exhaust, fireplaces. Another natural example would be volcanoes. That produces our primary pollution. If those react with each other or something else, that will produce our secondary pollutions. You'll notice here these are your subscripts that wasn't showing up in the previous slides, and your superscripts with the negative numbers. Carbon monoxide and carbon dioxide is the primary source. They're mostly coming from burning organic materials such as coal, gas, and wood. Also from car exhaust and cigarette smoke. Sulfur dioxide comes from burning fossil fuels such as coal and oil. Nitrous oxides comes from burning fossil fuels, including car exhaust. Hydrocarbons. Hydro means hydrogen, carbon means carbon. So this has hydrogen and carbon in it. This comes from car exhaust, industries, and organic compounds. Particulates such as dust can come from ash from fires, volcanic eruptions, and dust from construction sites. Here are some examples of secondary pollution. We have ozone, which is O3. This can be produced when oxygen atoms and car exhaust type gases react with the sunlight. Smog is made of nitrogen oxides. This is a term that combines the words smoke and fog. The reason for this is it looks like smoke. It looks very hazy like smoke, but it acts like fog and lays low to the ground. But it's not smoke and it's not fog. It's air pollution. We also have acid rain. Acid rain can form from nitrous oxides, sulfur dioxides, and carbon dioxides. When we burn coal, a lot of sulfur dioxide is released, and that will generate a lot of acid rain. Aerosols and mist can come from industries. More on smog. In order to get smog, we have to have thermal inversion. Therm is a root word meaning heat, and vert means upside down. So normally in the troposphere, it gets colder as you rise up in the troposphere. With thermal inversion, it actually gets warmer as you rise up. So on a normal day, you see the air cools down as it rises as you go up. During the day, this will heat up, and any pollution that we're creating will rise up because it has a lower density than all the air above it, so it rises up and goes elsewhere. During thermal inversion days, here the ground is heating up, the smog rises because it has a lower density. However, if it reaches a layer that's warmer air, the smog is going to have a higher density, so it can't go any higher than the warmer air. So it gets trapped and it comes back down. Los Angeles is notorious for having a very smoggy air. You have cold ocean air coming in from the ocean. This air will hit the mountain and try to go up. However, if we have a layer of warmer air, it can't go up any further than that, so it gets trapped. It can't go towards the ocean because of the wind. It can't go over this way because of the mountain, and it can't go up because of the heat, so it gets trapped right here. Here's a picture of Los Angeles on what should be a clear day. What you're seeing is the smog. What I find is interesting is you can see a definite line up here. That would be your thermal inversion. This is the warmer air up here trapping the heat. This is an aerial view of the smog. You can see the mountains in the background trapping the smog. You can definitely see a elevation here of which the smog won't rise up because of the thermal inversion layer. London has also been known to have a few smoggy days, along with places in China, such as Shanghai. Some health effects for breathing a lot of air pollution. Short-term health effects are going to have irritation to the eyes, nose, and throat. You have upper respiratory infections such as bronchitis and pneumonia, headaches, nausea, allergic reactions, and if you have asthma or emphysema, they may get worse. Long-term health effects, you're going to have chronic respiratory diseases. Chron is a root word meaning time. So you're going to have respiratory diseases for the rest of your life. You can get lung cancer, heart disease, damage to the brain, nerves, liver, and kidneys. This will affect growing children and elderly the most. Anybody that has a body that is still growing and developing, even you as being teenagers, you're not fully developed yet, you're going to be much more susceptible to health issues associated with air pollution. It's estimated that 500,000 people die prematurely every year in the United States as a result for cigarette smoking because you're constantly breathing in a lot of that pollution.